Alright, so let's look at the first problem. The cost in dollars of renting a car for a week from Pricebuster's Rent-A-Car can be approximated by the equation C equals 0.13 m plus 340, where m is the number of miles the car is driven. So the first thing we need to do is identify the independent and dependent variables and explain what they represent. So the equation, or the variable that the equation is solved for, that is going to be our dependent variable. So we're going to say the dependent variable is C, and we have to say what that represents. So the dependent variable is C, which represents the cost for driving the car for 1 week. Now, the independent variable, that's the variable that you plug into the equation. So, in this case, m is going to be the independent variable. So, we're going to say the independent variable is m, and that represents the number of miles driven in a week. Alright, so we have our dependent variable and we have our independent variable. Alright, now it says at the end of the week, a customer owed $396.16. How many miles did this customer drive? So if this is what the customer owed, that's going to be a value for C that we're going to plug in. So I'm going to replace C with $396.16. So I put it in place of C, and now what I need to do is I need to solve for m. So I'm going to subtract 340 from both sides of the equation, and that's going to give me $56.16 equals 0.13 m, and then I would divide both sides by 0.13, and I would get 432. So this customer drove 432 miles. Part C says, is the relation a function? Right? Yes, it is a function. Now there's a couple ways we can explain it. The first way is to rewrite it in the form of y equals mx plus b. So if we replace c with y and m with x, we have y equals mx plus b form, which is linear. And we know that all linear functions, all linear equations are functions, so yes, it's function, and we could say yes because it's linear. Another way to think about it is to think of all the input values and how many output values they have. So another reason why is because each input value has only one output value, meaning each value we plug in for m, for the number of miles, there's only going to be one cost associated with that. So for every m that we plug in, there is a unique value for C. Alright, part D, what is the y-intercept? So the y-intercept is going to be the ordered pair 0, y. or you could think of it as 0 comma c. But if you think about it as the y equals 0.13x plus 340, we're trying to figure out what the y value is when x equals 0. So if we replace the x with 0, y equals 340. So the y-intercept is the ordered pair 0 comma 340. And what that represents is there's probably some kind of flat fee for renting the car. So even if you drove 0 miles, you still had to pay $340. So we'll say it represents a flat fee, or you can say an initial fee maybe, a flat fee of $340 to rent the car even if no miles have been driven yet. Or maybe it could be some kind of deposit that you have to put down, and then on top of that you pay for your miles. Alright, part E of feasible domain. So remember, that's all the x values or the independent values, which in this case is miles. So if you think about it, you can't have a negative amount of miles. So we're going to start with 0. And I'm not going to include 0 because it really wouldn't make sense that you would rent a car and not drive it. So why would you rent the car and not drive any miles? But then there's really no limit as to the amount of miles that you can drive. So we're going to go from 0 to infinity. Or if you want to write it in set builder notation, you would have m is greater than 0. Alright, let's look at number 2. So car companies occasionally offer qualified buyers an incentive of 0% financing and no money down. Ethan just purchased a new car under such an agreement. The amount of money A that he will still owe the company after n monthly payments have been made is given by the function a sub n equals 34,515 minus 575.25n. So the first one says evaluate a of 0. So we are going to replace the x value, or in this case the n value, with 0. And that just gives us the 34,515. So what that represents is that's the amount of money that he still owes before making any payments. So we could say that 34,515, we could say that that is the purchase price of the car. Because again, that's what he owed before he made any payments. Alright, a of 24. So now we are going to evaluate the function, and we are going to do it when n equals 24. So we're going to replace the value of n with 24. And this comes out to be 20,709. Because you'll do your multiplication first, and then your final answer is going to be 20,709. So what this means is that he still owes $20,709 after 24 payments have been made. Alright, a of 72. So again, we are going to replace the value of n, or replace n with the value of 72. And after you work this out, you come up with a negative value, negative 6,903. No, this is not possible. Because it's not possible for him to owe a negative amount of money. So we would say that before 72 months, he will have paid the car off. So he will pay off the loan before 72 months. Alright, part D, after 3 years of making payments. So 3 years is equal to 36 months. So you're going to evaluate the function for 36. And when you work that out, we get 13,806. So he will still owe $13,806. Now part E, how long will it take him to pay it off? So now you want to figure out the amount of months. So we want to find the value of n such that a of n is 0. So we want to figure out the amount of months it's going to take for the value that he owes, or the amount that he owes, to be 0. So now 0 is our output value. We're going to put 0 in place of the dependent variable. So 0 equals 34,515 minus 575.25n. So if we add the 575.25n to both sides, 575.25n equals 34,515, and then after we do our division we get 60. So it will take him 60 months or 5 years to pay it off. And then the last one, determine the feasible domain and the feasible range. Okay, so let's talk about the domain first. Okay, so remember the domain is the independent variable, so n, which was the amount of months. So we already know that he's going to stop paying at 60 months, and he began paying up here at 0 months. And we're going to include 0 in this case, because if you plug in 0, it makes sense that you owe $34,515 before you made any payments. And we're also going to include 0 because that's the last payment. The range, that is going to be all the possible values of A. Okay. Well, at 0 months, he owed $34,515, and at 60 months, he owed $0. So the smallest range value is $0, and the biggest range value was $34,515.